All right, chapter 16, number 40, we have another organic base in water. This one is ethylamine. Ethylamine. Once again, you hear this, you're going to hear it a lot. This denotes your nitrogen with the lone pair, and ethylamine, so it has an ethyl group. That's 2 carbon backbone hydrocarbon, so that would be CH3, CH2, N, and that must be NH2. There's my ethylamine. And so let's abbreviate this as R. So this part is my R group, the part that involves the carbons. R, N, H2. I'll write it like that. Okay, that's my short form. Now when I put ethylamine in water, you don't have to short form it, by the way. If you want to write that out that way, that's great. R, N, H2. When I put this into water, as you know, it's a base. We hear that word amine. And that will ionize according to the value for Kb. And as a base, it will pick off H plus from the water. The water will therefore be the acid to donate that H plus. And it'll land on the lone pair here. So I will write it then on this side as RNH3 plus. Okay, so analogous to NH3 and NH4 plus, but one of the protons is now a carbon. So I've got RNH2 goes to RNH3 plus. This is aqueous, and it produces the basic medium, so I have hydroxide ion also produced. Great. What's the question asking in 40? What is the degree of ionization and what is the percent dissociation? Same thing, one's a fraction, one's a percent. Of ethylamine in a 0.85 molar aqueous solution, and they give us the pKa value. Actually, that pKa value was from another question. The pKa is not 4.89, so in the revised handout, that was crossed out, and it said you'd have to look up the pKa in the text. Why did it say pKa? Well, of course you needed a Kb, and but maybe just the pKa for this species is available, and so you have to do a little calculation in order to get go from a pKa to a pKb and then a Kb, and that was just part of the exercise. So that wasn't the pKa written there was not a typo. The number was incorrect. All right, so more on that in a moment when I need the Kb value. We do know that it is 0.85 molar, so that's where that number 0.85 goes. Okay, that's initial. If that's what's on the label of this flask, this solution is a 0.85 molar solution of aqueous solution of ethylamine, then that means that it goes here. Okay, we don't care about water, and again, there's nothing ionized to begin with. Minus x plus x plus x. At equilibrium, 0.85 minus x, x, and x. So here we go, we have Kb, and we don't know what that number is, but it will be equal to x squared over 0.85 minus x. So at the moment, I have two unknowns. I have to look up the Kb value. So if we look on table 16.3 in your textbook, we will find a pKb for ethylamine as being equal to 3.37. Now, let's say on the exam it only had a pKa table. Well, then that would be listed as 10.63, right? Because they have to add up to 14. You would see a pKa for this species, the protonated ethylamine, and that pKa value would be 10.63. Oops. But no sweat, because take it from 14 and you would get your pKb. And then we can find the Kb value from the pKb. Okay. Kb is what we need, 10 to the minus 3.37. And that is 4.3 times 10 to the minus 4. Okay, that's my Kb. So I have 4.3 times 10 to the minus 4 is equal to x squared over 0.85 minus x. And when I multiply this through, and just a little bit of rearrangement, I get a quadratic equation here that x squared plus 4.3 times 10 to the minus 4x minus 3.65 times 10 to the minus 4 is equal to 0. And I will apply my quadratic formula to these coefficients a, b, and c. And I find that x has a choice of two roots, 0.0189 and a negative 0.0193. So I disregard the negative one and I take this one. And therefore, this is x. So this is the number of moles per liter that actually dissociated. So my degree of dissociation is 0.0189, my x, over my initial 0.85. Okay, so that number there would be equal to, do it on your calculator and see what you get here. That number would be equal to 0.022. So that would be the degree of dissociation, 0.022. It's a fraction. But my percent ionization is taking that fraction and multiplying it by 100. And that will give me 2.22. But I'll report it as 2.2 for 2 sig figs. So it's 2.2% ionized, this ethylamine in water. So there's my final answer. Okay, so remember, the degree of ionization is just my fraction x molar over the initial concentration, so my change over the initial. And my percent ionization is this fraction times 100. And do you see how, therefore, my 5% rule would be fine, because since it's less than 5% ionized or dissociated, then this little thing up here, x, is probably insignificant compared to 0.85. Anyway, it ties it all together. Another good question, good exam question.